Hey, this is Brandon. You're watching the series where I solve every elite code daily and then get it on one line. So I want to try something different today. I want to just go through what I already did because I got up and made dinner halfway through and I don't really feel like editing an hour and a half of footage tonight. So let's go through the problem first. Let's get rid of that for now. So the idea is you're subtracting each of these by a prime one time, and then you're trying to make a strictly increasing array. The 4 you could subtract a 3 and make it 1, and then the 9 you could subtract a 7 and make it 2. Then you'd have 1, 2, 6, 10, and then you'd be good. It's not immediately apparent what to do, and the constraints are pretty lenient. 43% acceptance rate is like not high. That's like a hard problem. So, but you could do O of n squared, or you could do O of n times m. What I was thinking was you just create a sieve up here, aka like all your primes from 1 to 2 to 1000, or 997 I think is a prime. Yeah, so it's going to be all the primes in here, and you pre-process that, so that happens in test case 1, and then every other test case that doesn't happen anymore. And then in here you kind of just say like, okay, go through for x in A, subtract by biggest prime. And then if the previous x is bigger than this, then you're fucked and you return only. And then here, return true. That's the basic idea. So this is that pseudocode, but as actual code. Interesting that I just left a print statement in. That's kind of funny. So I say, all right, create P, aka the array of all the numbers that could be a prime. So the index is the number, and then it's either 1 if it's a prime or it's 0 if it's not. So 0 and 1 are not primes. And then I go through and I say, all right, if not P at I, then this number's not prime. It's a multiple of something else, so just continue. Or else it is prime. So take every multiple of this, start at 2 times the current number you're at, go up to the end of the array and increment by this number. So take every multiple and make sure that it's not a prime. And then this is a fancy little way of just saying like, get every index where there's a 1. I'm saying p.getItem is either going to give it a 0 or a 1. And then I'm applying that as the predicate for this filter function that just says like, take everything in a sequence and only give me the ones that are true. So I'm taking everything from 0 to 100 and I'm only returning the ones that are denoted as prime. Okay, so now I have this primes array and its length is 168 because there's 168 primes below 1000, which works out. And then I just do exactly what my pseudocode said. So if previous is bigger than x, then you're fucked. Find the biggest prime in primes, subtract x by that, because you always want to do that. You never want to subtract a number by less than that, by a smaller prime, if you only get one prime. So it's just it's like a little binary search through primes. And then that's the new prev. There's a little bit of footwork around the first element, but that's pretty much it. The time complexity for this and all the subsequent solutions. So the number of primes is n over the natural log of n, if I'm not mistaken. Like if you just take the number of primes below a certain number, I think it's n over log n, but log base 2 point whatever. So if I say like ln 1000, 6.9, and like 1000 over 7 is roughly 168. So with that in mind, the length of primes, if you increase like the maximum possible numbers in A, the length of primes would increase basically linearly, right? Like n over log n is kind of just O of n. So this kind of is just O of log n asterisk. And then you're doing this for every element. So it's like n log m, where m is the maximum element. Pretty speedy. And you're only calculating the primes once. All right, so I just got my previous code on one line, and I figured like reduce is a pretty simple way to do it. I didn't want to bother with getting rid of lambda. That sounds like a lot of effort. Getting rid of lambdas is more fun if there's some sort of like parsing you're doing. It's just like too much going on, I feel like. I say that even though the loop was only 3 lines long. So reduce says like fold up your array. So if we have 4, 9, 6, and 10, it's gonna say, okay, start with a 0, then look at 0 and 4, come to some sort of conclusion about that, and then take that number you came to, let's say you're adding them, then you would have 4, take 4 and 9 to come to some conclusion about that, so 13 if you were adding them, 13 and 6 you get 19, 19 and 10 you get 29, and then it would return 29. That's like what reduce of this array would do. But you can give it a custom function to be like, don't just add them, like do this thing that I want you to do. So like reduce XOR or something like that is useful sometimes. So here, what I'm basically doing is I'm saying like, what the fuck does this question even mean? Oh yeah, here I'm saying like take these two elements, give me the new prev. So this is like x is prev and y is x from this previous thing. So y is like the current element and x is whatever we just got, so prev. And then we're going to return the new prev. And basically my thought process is like the way that I can, instead of early returning false, there's not really an elegant way to do that with a reduce. I don't think there's any way to do that. I just say like if there ever is a situation where you want to return false, aka x is greater than or equal to y, just return infinity. And then everything after that will be infinity, and then just check, did you reach infinity? Because if you didn't reach infinity, if you reached some other number that's like the minimum that the last element can be, then you're good. So I just say get the index, subtract that prime, and then take that, whatever you subtracted to get, like take that element. So then I was thinking, all right, well, it's kind of a one-liner, but I could also just like have this be ands equals something, and then something like that. So it doesn't really mean that much to get this on one line. I mean, it kind of does. I actually think that means a lot, but then I'm thinking like, all right, well, I'll at least get the primes on another line or on its own line. So I do that. It is actually quite complicated. It's more complicated than the actual solution because here you're modifying p in place. So you have to create it, say, okay, 0 and 1 aren't prime, everything else could be prime. And then the next thing I do is like have this map object that I unpack where it doesn't do anything except modify p in place. So that's where it's like star map p dot set item. This was actually quite a little work of art here. And then you extract all the ones from that as before. So you're getting every index where the answer was 1. So like 2, 3, 5, 7, 11, so on. And then this is the same. And then the final one, I'm kind of just consolidating this line into this line, except I renamed primes to p. I renamed it to self.p. So what I do is I say, check if you have a primes array. If you don't have that, then do all of this, then build the primes array. That way I'm still only doing it for the first test case, and I have this persistent array of all of those primes without having to recreate that every time. So I have like persistence through this one line. When it's called multiple times, there's like the primes array that persists through calls. And then there's the normal, does the reduce of everything, does the smallest number you can get at the end of the array equal infinity or not? And that's it. This one's a little slower, which is interesting to me. Maybe it does just do this every time anyway. Like maybe on the other end, I could see it just flushing self or something. I don't know, something like that. This did not print true. Okay, none of them did. Interesting. And then here I can say print self.p. Interesting. So it does set self.p to be that. I guess it just resets after every test case. I can't really think of a way to declare it as a global. That's pretty crappy, actually. Whatever. So I guess this one is like O(n squared. What are you gonna do? Thanks for watching.